In this video, I'm going to explain how we're going to do compare the function and its inverses. So the topic, the objective is comparing a function and inverses. Okay, first of all, we have to look for the functions and what the inverses and functions are. So if I have a table, like for example x, and this is my f of x table, this is my y f of x function, the original one. So I have negative 1, 0, 1, 2. This is also called my domain. And this is also called my range. The y is always range, x is always domain. So my range or my y values are 6, negative 7, 4, and 0. Now let's get the table for the inverse. So this is x and this is inverse. Inverse notation is always notation for inverse function is always going to be like this, that's negative 1 on the top. So this is my inverse function. Now, how are we going to write the inverse function domain and range? Always make sure the domain of the original function is always going to be the range of the inverse. So all these values, negative 1, 0, 1, and 2, they're going to go as a range of inverse. So 0, 1, 2. All these range values, like y values of the original function, is going to go as a domain of the inverse. So what we did, we switched x and y's. We switched domain and range. So the domain of original function is the range of the inverse function. So that's how the domain and range goes as an order pair. Now, if you have graphs, then how would you decide about the domain, about the inverse function? So always make sure, like for example, I have a graph, and the graph is something like, I'm starting here, and the graph goes like that. So do we have inverse of this? So you're going to draw y equal x. This is y equal x graph. If this graph is reflection on across this y equal x, then yes, that's the inverse. And that's the original function. So if there is a reflection across y equal x, then the function has an inverse. Okay, similarly, I'm going to show you some few other graphs that most of the students get confused on. For example, I have a graph. This is a graph, I'm starting here, and this is going in this direction. For example, this is my original function. So the question is asking, let's try another one. The question is asking, this is my g of x. So is the g of x, the question is the g of x is the inverse of f of x? I don't have the equations. I don't have order pairs. I mean, I do have order pairs. You can pick the order pairs up here and up here, any order pair, and see if the x and y is switching. But the easy way for doing this, you're going to draw that y equal x between them. And can you tell me if g of x is the reflection of f of x? I would say no, because if that was f of x was the reflection, then don't you think this reflection is going to go somewhere over here? Like this is going to go something here. and this is like smaller, the g of x. It start from here, that one start here. So it has to be like really a good reflection. So this one, no, that's not, no inverses. If I have a graph, another one, the graph starts here and the other one starts here. This is g of x and that's f of x. Is g of x is the inverse of f of x? Yes. Why? Because this is when this reflect, it's going to go up there. There is not that much difference in there. Like, do you see? This is 1 as an x value, then this is going to go as a 1 y value because x and y switches. So that's what it is. If in this case, so yes, we have inverse. Now, if the graph is something like this, like one graph is going, I did explain that one. So I think right here, the other one starts here, right? And I draw this, you can tell if this is -1y value, then this is -1x, and it's a reflection. And they are exactly on the same side, like same distance, like not one bigger, one smaller or anything. So yes, that's also inverse. We are reflecting f of x over here, and that g of x is the inverse. So yes, that's how it's going to work. Now, another example that I'm going to show you, for example, I have this graph. One f of x graph goes like that. This is my f of x. The other one, g of x, goes like this. And they're asking if g of x is the inverse of f of x. I'm going to draw my y equal x like that. And you can tell there is no reflection there. And one more thing, this intersection supposed to be up here, and this line and the other two functions supposed to intersect at the same spot. So this intersection supposed to be here. Like if I move these two graphs up here, then I would say yes, there was reflection. So the intersection supposed to be common for all the three graphs, f of x, g of x, and my y equal x. So the intersection is not, the y equal x doesn't have that intersection, the one we see on f of x and g of x. So you can say no inverse. G of x is not inverse, not inverse. So this is one thing. Now let me give you more examples for all of this. How do we figure it out if the question is f of x, y-intercept is just a note, write it down somewhere so you won't forget. The f of x function, the y-intercept of f of x, which means x is always 0 and y some kind of number. And the inverse is going to be inverse f of x. That y-intercept that we had for f of x for the original function is going to be the x-intercept for inverse. Intercept for inverse, which means the y is going to be 0. So we switch that. Now, for example, in the table that we had before up here, what is my y-intercept for f of x function? Y-intercept means when you have a x 0. So if you guys check this out, this is my y-intercept, right? So I'm going to write my f of x has a y-intercept 0, -7. Then what do you think the inverse x-intercept is going to be? We switch. We're going to have a -7, 0. You see the x and y is switched? Then this turns x-intercept for inverse function, but for the original it was y-intercept. And you can check in the table right here, it's the same thing. Look, they switched. So this one we call x-intercept because y is 0. This one we call y-intercept because x is 0. And that's what my y-intercept and x-intercept look like for inverses. Now I have another table that I want to explain it. I have x, and that's my original function f of x. I have negative 2, 0 into, this one is negative 1, 8, and 13. Now I'm gonna find out my inverse, and you know we're gonna switch to x and y's. So this range is gonna go domain 8 and 13. This one x, the domain is gonna go as a range for this. So this is what I got. The question would be asking, what is the f of x minimum and what is the f of x maximum? Now minimum and maximum means you're looking for the y values. So minimum, which one is minimum? You look for the y value, which one is the smallest one? Negative 1 is the smallest one. So the order pair negative 2 and negative 1 is my minimum. Like I said, minimum and maximum, always look for the y values. The maximum is going to be 13, 2, and 13 for the original function. What is going to be for the inverse of x minimum? The minimum is going to be negative 2, right? So it's negative 1 and negative 2. And if you pay attention, look at this. They switched their positions. Then what is going to be a maximum for this? It's going to be the inverse. For example, it's going to be 13 and 2. And again, these two switched, x and y's. So that's how the maximum and minimum goes. Make sure you guys also understand that f of x, any function, must be noted down somewhere, must be 1-to-1 for its inverse to exist. F of x must be 1-to-1 for its inverse to exist. What is 1-to-1 means? 1-to-1 when the function can pass horizontal line test. Like, for example, y never repeats. If you have order pair, you can see y never repeats. So 1-to-1 function. Okay, so I was explaining if f of x must be 1-to-1 function, which means it has supposed to pass a horizontal line test. If I have a graph y equal x squared like a parabola like this, then the question is asking if f of x has a inverse function. Is this function has an inverse function? This one does not have inverse functions because it is not passing the horizontal line test. Horizontal line goes like this. If it touches the graph twice, then it doesn't have inverse. More than once, if it touches it, then doesn't have inverse. So this one doesn't have inverse. But if I have the same, it says no inverse, because it's not passing the horizontal line test. Horizontal line test supposed to touch the graph once. Only touch the graph once. Graph once. Only once. Now, if I have the same graph, for example, I have the same graph. In this side, do we have this f of x function has inverse if we have restrictions x greater or equal 0. X greater or equal 0 means I'm only talking about this side of the graph, only this side of the graph. Do we have inverse of this side of the graph because of the restrictions? X is greater or equal 0, like equal 0 right there, and it's greater goes in this direction. So yes, because it is going to pass that horizontal line test. It touches the graph only once. So yes, we have inverse. If we follow this restrictions, then yes, we do. Okay, for example, let's try, let me show you for the linear graphs. If I have a graph or function 5x plus 14, and the inverse of g of x is going to be 1/5 x minus 14 over 5. So look at this thing. This is a linear original graph. The slope is 5. For this one, the slope is a reciprocal, 1/5. So if I have a y-intercept, this is a b. B means y-intercept. B or y-intercept. You know this is y equal mx plus b. This is y equal mx plus b. So this b is 14, which means it's a y-intercept. Y-intercept means when x is always 0. So I have 0 and 14. That's my y-intercept. What about here? What is this? So in here, the y, I explained this before. This is y-intercept. Then for the inverse, this is going to be x-intercept, not y-intercept. So what is my x-intercept? It's going to be 14 and 0. X-intercept means when y is always 0. So this is, I'm repeating that again. Now, let's figure it out. Another example. I have a graph. This is 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. So my graph is right like this. It's on 4, and this is 1, 2, 3, 4, 5, 6. So this is how the graph looked like. So the question would be, or maybe the question is asking, what is the range of this graph? Range means a y value. So you know I'm starting, the y value starting at 6 and it's going towards infinity, because these arrow means the graph's going forever. So it's going positive infinity. So it means I can say y range is greater or equal 6. Like it's starting with 6. And why did I say equal? Because of the closed circle, and it's going in that direction. Now, how the domain is going to go? What is the domain of this graph? The domain is 4, right? And it's 4, but it's also the domain of the inverse actually. The domain of inverse is going to be x greater or equal 6, because we switch the x and y's for the original function and for the inverse. So domain and ranges, they flip, they change, they switch. Okay, another example is that I have is f of x equal 2/3 x plus 12. In the question asking what is the y-intercept of f inverse x. So I'm looking for y-intercept of the inverse. So this is what I'm looking for. And we already know this function looks like y equal, this is mx plus and b, and that's y equal. So I can see all of that. That's my y-intercept for the original function. Y-intercept means when x is always 0. So if they're asking the y-intercept of inverse, then please don't think this is my y-intercept of inverse is going to be the same thing. No, it's not. You have to change the function to inverse function and then find the b, like this constant number. So I'm going to change this to inverse. This is f of x, and I'm writing it as a like y 2/3 x plus 12. Why I'm writing this? Because I want to show you that in inverse function, we have to switch the x and y's. Replace the y with the x, replace the x with the y, and get the y by itself. So if I get the y by itself, it means I'm subtracting 12 both sides. And this is going to give me x minus 12 equal 2/3 y. Now I have to get rid of this 2/3 so I can get the y by itself, and it should look like y equal mx plus b. So I'm going to times 3 over 2. Always multiply the reciprocal. You multiply the reciprocal with this one too. They cancel out, and I'm left with y equal 3 times x is going to be 3x over 2. 3 times 3 half times negative 12. So I'm going to multiply this minus 3 halves in 12. Now I simplify this. That's going to give me 6. Now I have y equal 32x minus 18. So this is actually my inverse function, and I'm going to change to the inverse notation, which is f negative 1. This is my inverse. Now you can tell what is the y-intercept there. It's this. This is my y-intercept for the inverse. So y-intercept means when x is 0. So I'm going to say x is 0 and then y-intercept is 18. Y-intercept means when x is always 0. So this is my answer for that question. Okay, let's go to find x-intercept of inverse. So I'm going to go for another example. I have a function f of x equal 3x minus 2. The question is asking find the x-intercept of inverse function right there. So what does x-intercept means? X-intercept means when y is always 0. Okay, so I can't find the x-intercept unless I get the inverse first. So I'm going to change that to y equal 3x minus 2. This f of x, I changed it to y, and that's exactly what it means. Now I have to switch my x and y's to get the inverse. So y replaced with x replaced with y minus 2. Then I'm going to add 2 both sides. So I got x plus 2 equal 3y. You divide 3 both sides. So I'm left with y equal 1/3 x plus 2/3. Now, if you pay attention, this is the inverse. So I'm going to change to my inverse notation so we don't get confused that either this is original or inverse. So that's my inverse function. -1. That's my inverse function. So if they are asking for x-intercept, it means make the y 0. So I'm going to write my inverse here, and I'm going to plug in 0 for y. I'm going to plug in, this is a y value, and I'm going to plug in 0 there. Guys, this is really important that you write x-intercept, y-intercept as an order pair so you don't get confused where I'm going to substitute 0 for x or substitute 0 for y. So if you write this, then you can clearly see it. So 0 here, 1/3 x plus 2/3. I have to get the x by itself. So I'm going to subtract 2/3. I'm going to subtract 2/3. They cancel out. And I'm left with -2/3 equal 1/3 x. Then you times 3 over 1 times 3 over 1. So I'm left with x equal 3 times -2 is -6, and 3 times 1 is 3. You simplify this, it's going to give me -2. So what is my x-intercept? It's -2. How do we write it as an order pair? -2, 0. Like that. So that's how you find x-intercepts. Now, some graph questions. Let's do the example. I have a graph. This goes like that all the way. That's my f of x function, like the original. This is my g of x function, which is inverse. Now the question is asking, what is the range of the original? What is the range of f of x. Find the range of f of x. And also find the domain of inverse function, which is g of x. Okay, make sure that you understand g of x is my inverse function. F of x is my original. So I'm going to make this in this same color so you don't get confused. Maybe just erase that and write down with the different color. F of x is range of f of x they're asking. Okay, let's find the range of f of x. Now, range means a y-axis, like a y values right there. So always start your pen or marker from the bottom. Always go the smallest number in range and domain goes first, or any order pairs, or any, not order pairs, I'm sorry, domain and range. And if you are looking for minimum maximum, always the smallest goes first. So I'm starting with this negative infinity for the y values. I'm going. I stopped right there because my graph is starting at 0. I mean, this is supposed to start like all the way like 0, like this. So I'm starting with, the range is 0. I'm starting with 0. Then I'm going to go all the way where I'm going. I'm going towards infinity, positive infinity, this. So that's my range. And you know, for the domain of the inverse, we always switch to x and y. So without even looking at the graph of g of x, like the inverse graph, I can tell my domain of the inverse function is going to be infinity and 0. So I'm starting the domain of the inverse, this one. So I'm starting with all the way domain to 0. I'm sorry, no, that's not, I made a mistake here. This one, okay, pay attention one more time, please. Range of f of x. Range of f of x is starting with 0 and going to the infinity. Yeah, that was correct. The domain is gonna be, for this is, I'm starting 0 and going positive infinity, would be the same thing. Yeah. If this is the range of the original, then this is the domain of inverse. That's what it is. Okay, so we can write this. We can say f of x range y greater than 0 and domain of inverse is x greater than 0. So this is x domain, that is y range for the f of x function. Now we have another graph example. Guys, please make sure that you understand this. I was doing it right, but I thought I'm confusing myself with switching thing, but it's already switching. If this is range, then that's a domain. Another example that I have a graph right there. This is 1, 2, 3, 4, 1, 2, 3, 4. This graph is starting here, going in this direction. That's my original graph, f of x. Another graph is 1, 3, and it's going in this direction. That's my inverse function. You can see, sometimes they use the notation f negative 1 in x, which we can tell that's inverse. Sometimes they tell you that g of x is the inverse. They don't put that negative there. Okay, so the question is asking, what is the f of x domain restrictions, or you can say what is the domain. So the domain for f of x is starting with 3 and it's going to infinity. So I'm going to say that x is greater or equal 3. That's what it is. Now, if they are asking what is the f inverse, you know, if I have a domain of the original, then this is going to be my range of inverse. So it's going to be greater 3. And you can tell from the graph that's what it is. Okay, now there is just one last question that I want to share with you guys. And that last example is right here. One is f of x equal x squared plus 3. Then they said the inverse is now the inverse is, I want to keep different colors, negative square root x minus 3. Now the question is, they give you different options. Like for example, number one option is, let's do this in different color. Number one option is the domain of f of x greater than or equal to 0 in the domain of the inverse. I'm just going to write inverse on top of this. Of the inverse is x greater or equal 0. Second option, you have the domain of f of x is x greater or equal 0 in the domain of inverse function is x less equal 0. Third option, the domain of f of x is x less equal 0. The domain of inverse function is x greater or equal 3. Number 4, the domain of f of x is less equal 0. The domain of f inverse x is x less equal 3. So now the question is asking which one is correct. And I tried my best to do to get these things. Now the question is asking what is what. Now I have this actually 3. So the question is asking which one is which. First thing first, I would graph both of these functions to my knowledge, or use a calculator to graph both of them. Use Desmos to graph both of them. If I graph this, then I know plus 3 means it moving up 3 times, and that's my graph. This one is actually the parent function for that is supposed to be like this, like that. But since this is negative in the front, which means it's a reflection across x-axis, and I'm going to the right 3 times. So 1, 2, 3. So I'm starting here, and it's a reflection across x-axis. So I'm going to make it the same color. So it's going to go something like that. See, this one reflect across x-axis, and it went back to this. So these are my graphs. Now, how do you answer this question? You're going to go one by one each answer and see which one is true. So let's try the first one. They said the domain of this function is x greater equal 0. So this is 0, and I'm going x greater equal 0. So I'm starting with 0 and I'm going greater than 0. So yeah, that's true if that's the restrictions of this function. Like, I'm not saying, I know the domain is going negative infinity to positive infinity, but I don't have that choice. The only choice we see is x greater equal 0. Does it work for this function, original one? So yes, I'm starting with 0 and I'm going to the infinity, like I'm going greater than 0. So yes, greater than 0. So this one works for the f of x, so correct. Let's try that one. The domain of this is greater than 0. They said the domain is greater. Actually, the domain is not greater or equal 0 because I'm not starting with the 0 like that one. I'm not starting. I'm only talking about this side of the domain actually. So no, I'm not starting with 0 here. I'm starting with 3 and I'm going greater than 3. So this one is correct, but that one is not correct. So this is gone. Try second. X greater equal 0. I know we already said that it works. Does it work here? Less than 0. It doesn't work less or equal than 0. If it was less equal 0, then it's supposed to go in this direction, like equal 0 and less 0. So this works, but that one doesn't. Cross. Next, x is less or equal 0. I know I do have that too. I'm going less than 0 or equal 0. So yes, that's true. But is this true? X greater or equal 3? I am going 3 greater and I am starting equal 3. So yeah, that one works. So I'm going to keep this in my mind and let's try the fourth one. X less equal 0. Yes, I already said less equal 0. This side of the graph, if we take that restriction, it works. Then if you do get x less or equal 3, this is greater than 3. Like I'm going towards 4, 5, 6, 7, 8, 9. I'm not going backward. So this one doesn't work. That one works. So my choice is this one not. My choice is 3. If you guys have any questions, please comment below and I will try my best to answer it.